Well, I think we can start because I had some Neville sent me a message saying that he won't be able to join. Then Michael did the same, and usually Josh isn't able to connect because of work. So I think we can start right now. So first of all, have you? Well, I guess I know Thomas already did it and showed us what he understood about the code. What about you two, Enrico and Harris?
I'm still playing with it. I actually have a question, Patrick. What would be the best way, in your opinion, to kind of work on the repo on the side? I mean, should we fork it, clone it? Should we start our own?
I've thought about that a little bit. I think yes, the best way would be to fork it.
Okay.
Because, well, I know. I mean, you can perfectly also use the same repo, create your own branch on locally, but then you won't be able to be publishing these branches. But it doesn't matter. I mean, it's not something that is, catastrophic if you lose it, if your hard drive crashes. So as you wish, you can fork it and work on the side, or you can create your own branches locally and work locally on the different branches. Or I don't know. It's quite hard because in one hand we want to keep the code like a master version of the code, and on the side you also want to play with it and make some changes. Also save those changes and don't want the changes to be overridden by the new push to the branch. So I understand it's not easy. So yeah.
If we fork, we'll be able to pull in your latest, like what you have on master. Once you fork, it's separate, right?
Yes, yeah. That's the problem. So what I could do, it just popped in my mind. What I could do is create a branch for each one of you.
Okay.
So then you could work.
Then we can always pull in from master.
Exactly. Yeah. If you want to update your branch with the master code, you can merge it. Or if you just want to go on with your own code, then you can go on working with your own branch. It could be a solution.
Yeah, and then you can just block pushing to master, so that accidentally override master. Yeah.
I don't know. Actually, I haven't tried it. I don't know if you have the permissions to push to master. Or I don't know if you have to make a pull request on GitHub. I don't know.
Yeah.
We have to check.
Oh, that's right. If you set it that you can only merge with master through pull requests, then it means it won't happen, right?
Yeah.
Just don't want to overwrite master. Yeah.
That will be cool.
Yeah.
Okay. So I don't know, Harry, have you worked a little bit with Git before? Do you know Enrico also? Do you know how it works? Or
Yeah. I know the basics.
Okay. So working with your own branches, well, it's actually very easy with VS Code because you choose the branch on the little menu on the left down bottom side, and that's it. So it's pretty easy. Okay, so let's start. I haven't thought about how to do it, so I'm gonna improvise on the run. So let me put that, maybe a little bit too big. Is that okay? Can you see the code? Is it too big or too small?
Perfect.
It's fine.
Okay.
Yeah.
All right. So I don't remember what we did last time. I think we already commented the user service, correct? We talked about those changes. We did that last time, I think. Yes. So what I've done and what I have explained on the chat, I've moved some of the code that we had from the core module to its own module. So it doesn't change the logic, but the reason behind that is, again, we are focusing on a mobile application. So there is, let's call that a KPI, or a metric that is critical when you work with a mobile application, which is the first meaningful rendering of your app. So in plain words, it means how long does it take for the app to show something useful to the user. Okay, so if this time is longer than, I mean, the standard is 3 seconds, but this is obviously every day the networks are faster and faster. So 3 seconds seems like an eternity now. So I would say it has to be 1 second and a half or 2 seconds at most. If your app can't display something before that, then you're starting on the wrong foot. Okay, you're giving a bad impression. It looks like the app is almost, busy doing, you don't know why. You don't know why, because it's not doing anything. It's just showing a splash screen saying welcome to blah blah blah. So that's why I changed that. Okay, so it's not really important. It's just because our app is very small, so it won't be very, very heavy, and it won't take long to load. But it's a good practice. If you don't need something at the beginning, just don't load it. So do not load it. What you have to do is to put it in another module and load this module asynchronously on lazy loading. Okay, so we have the core module, which is loaded since the beginning. But then if we go to, I think it's, where are the routes? The routes are, okay. Here it is. Okay, so this is the routes. This is something I wanted to explain to you, how routes work in Angular. So this way of defining a route is, let's say, delayed. Okay, so basically you're saying in your route, when the user is going to this URL, so it would means your domain /login, then run this function, and this function will import the module. Okay, but it won't import the module from the network or from the server until you reach that URL. This is lazy loading. This is what I mean. What it means. Normal loading, it will be just to here, instead of putting load children, just state a component and say which component has to be loaded to show the screen, and this component obviously has to be already downloaded, so it's not lazy loaded. So we're gonna keep it this way, and we're gonna start with routes, and we're not gonna go very deep into routes because it's very, very complex, but for simple stuff, it's very easy to use. So I don't know if you already know all I'm saying, just please stop me. Don't make me waste my time and yours. All the application we're talking about, whether they are built with Angular or React or whatever modern framework, are called SPA, single page application. And this is a paradigm different from a long time ago, where pages were rendered on the server and there were many pages. Each time you click on the link, you were actually requesting a new page to be generated on the server and retrieved from your browser to your screen. So it was many pages. Nowadays, what we do is we use single page application, where we download an entry point, which is the actual index.html file. And from there, we navigate dynamically inside the same HTML page. Okay, we don't ask the server for a new rendering of anything. We just get the code, and then thanks to the framework and therefore to JavaScript, we just add new HTML to the same page. Okay, but if you do that, it's okay, but there is an issue. You can do this without any kind of routing. You could do this with buttons and navigation components on the screen, and you could navigate through the whole application and work perfectly without any issue. But what would the inconvenience of that is in your URL bar, the direction, the address will always be the same. It will be the indexed HTML address, and that's it. So you won't have any. You won't be able to access any specific part of the app thanks to a URL. And this is very easy to use when you want to go straight to a part of the app. So that's why all those framework you implement a routing system, and the routing system is just a way to match where you are in the app with the URL address of the app. So it's not a real URL. Let's say that when you're working with an SPA, single page application, and you enter a URL with a /something/something/something, you're not actually requesting to the server to generate a new file for you. You load the first file, and then the router take care of the rest of your URL and generate the requested component dynamically on your machine, not on the server. Okay, so that's why you need routing. So Angular routing. So you have a router module. You have routes. You have to import everything, but usually it's already when you create a root file, thanks to the ng command line, it does all the import for you. And what it gives you basically, it gives you this. This is the bare minimum file for a routing file, and they will be generated by the CLI. So after that, what it tells you is that here there are just two meaningful parts. The first part is the root array, and the second part is where we use this root array. Okay, so the root array, it has a specific syntax that you can check thanks to TypeScript. It gives you all the easiness to work with, and basically it follows the same model for every route you want to create. So it's an array of objects. You have in each of those objects, you have to have a path, which is basically the URL you want to match, and then you tell the system what you want it to do when the user reach this path. So you have two possibilities, as I said before. Either you load a new module, and we will see that afterward, or you just display a component. Okay, so we could create a new route here. We could say, okay, path test. When you specify the path, you don't include the slash. Okay, and then here component, and then here we can use a component that we already have somewhere. I don't know if we have. We haven't created any component, I think, or did we?
Don't we have one for Alf?
Yeah, here, sign up, for example. Okay, so this is the way to do it. So what that means is, let's imagine that my root URL is www.myapp.com. Okay, so if you go to myapp.com/test, directly on your browser, what the browser will do is to ask the server for the index.html. It will load the index.html that will point it to some JavaScript. It will execute the JavaScript, and then it will try to go to the specified URL. In our case, it's test. But this action of trying to go there will be intercepted by the routing module, and it will be, instead of actually making a request to the server, it will generate the sign up component on the screen. Okay, that's it. And where you're gonna, the logical question is, where is it gonna be rendered? Well, here we are in the highest level. It's the app component. As you can see, there is a router outlet component. The router outlet component in Angular is just a placeholder where you're going to display all the components that are loaded by the route that you are requesting. Okay, so in this case, it will be, if we go to test, inside here, it will render our sign up component. Okay, that's it. Something which is very important now, I say that here you can define all your routes and all the lazy loading that you want to do. There is a specific syntax for defining the route. As you can see here, there is some specific path to match some default. If you put something that doesn't exist, it will redirect you to login. If you put nothing, it will redirect you to login. It's sort of a fail-safe in case the user just types something that doesn't exist in the address bar. And then the other thing, yes, Sam?
Yeah, Patrick, I was wondering, the router outlet, there can be only one router outlet, or there can be multiple of them?
Oh, there can be multiple one. I'm coming to that. Good question. I was actually getting to it right now. So here, as you can see, we have defined our root array. So many components for many addresses. And this is the app routing module. So it's the highest in the hierarchy of routes. So it's the entry point of the app. So since it's the entry point of the app, we initialize, or we load, let's say, this route configuration into the router module using the for-route function. Okay, so this tells the router module that these parameters have to be used for the direct access from the root of your URL. So if the root is myapp.com, it will be just what is after the slash. It will be the first entry point. Now, to illustrate what Sam just asked, we talk about lazy loading. If you talk about lazy loading, it means that when the user gets to this part, it won't load this. It won't load the auth module. It will just load this and the app component, and that's it, nothing else. But then if we go, if there is a button in our page to go to the login page, or if the user type login into the address bar, then Angular will load the auth module. Okay? It will check the file, and then it will execute the auth module. So let's go to the auth module, which is just here. Okay? So the auth module is just, as I said, a module is just a place to declare everything you're going to use inside, let's say, this let's call it a sort of a namespace. No, it's not a namespace itself, but it's a space inside the app which is embedded. Everything is embedded inside. So we use common module, which is always there for Angular. We use the auth routing module. Well, we have another routing module which is specific to the auth module, and this is this file. And again, it's exactly the same structure. So we define some routes here, and then here, when we want to inform the router module of this new path, we are not informing it that those paths or those routes are from the root, but are just for this module. So they are child. They are actually, it would be children, not for child, but children. Okay, so you have the root, the root, which is here, which is the top level of your routes, and then so here I'm going to write here. If you go to www.myapp.com, okay, if you go to this address in your browser, it will be directed to this file, okay? And as you can see here, what it says is whatever you put here, whatever you put after the slash, it will automatically redirect you to the login page. So when you get here, the router will redirect you to the login page. And if you go to the login page, it will then load this module. So now you're here, you're in the login, okay? And it goes to the routing module. And inside the routing module, we could have another one, which is sign up, for example, okay? And here, if we want to go to sign up, we have to go here, okay? Because those routes are children of the root one. So this is the way. This is the way to do, let's say, a hierarchy of routes. And as Sam mentioned, I'm not going to save. Nope. Where am I? So in the app component, we have this router outlet. Okay. So everything has to come together. So it's a little bit complicated to explain. So let's go. I'm trying to make my mind up on how to explain that. So if we go to the app routing module, okay, here it is, to the app module. So the app module will be loaded by default by Angular. So it's the entry point of the code. And here in the module, it says, I'm going to use the app component, and I'm going to bootstrap the app with the app component. The bootstrap means when the code starts, which component should I display first? Which is the entry point of the app? And here, this is where you inform the application where you start. Usually nobody touched that. It's always app component. So app component, it's this component. It has nothing inside, doesn't do anything, and it's related to the app component HTML. And the app component HTML is the one that contains the app router. Okay, so basically the app component has absolutely no role except of a container. It's the main container of the whole app. It's the single page application. Okay. So since in the app module, you are also referencing the app routing module, which is the one we were watching before. In this module, in this route module, everything you're gonna reach is gonna be displayed in the router outlet or applet. I don't remember the name. Outlet, the router outlet of the app component. And it will be the same with all subsequent module that you load. Okay, so if we go now to where is the app module? Okay, in the app module, we are saying we are going to use the sign up. And in the sign up, well, no, I've made it. I've done it very simple. But let's imagine in our auth routing here, we could, for example, for the no path direction address, we could create a sort of a generic container to make some, I don't know, some borders or define a background color or some stuff like that, and then display the rest inside. And that's where we would put the other router outlet to show the rest of the routes. So they are embedded in one in the other. I know it's complex. When when we go to the examples, it will be much easier. So basically, each time you have a new auth routing module and you want to display some stuff inside, you can use a new router outlet. Maybe you don't need it. You can just draw the thing or render the thing directly from there, or maybe you can need it. It doesn't. It's up to the logic of the code. If you have lazy module inside lazy module inside lazy module, so each time you have a lazy module, you need a new router outlet. Okay.
But on the same HTML template, you would only ever have one router outlet. These other ones would be on other HTML templates for other modules that are deeper in.
No, I don't think you can. There's
yeah, because it just needs one place to know what the routing could happen, right?
Yeah, because the routing outlet it's just here to display what is gonna be retrieved by a new lazy module loaded.
Yeah.
So once you load it, the new one itself probably will also need another lazy module. So it in its turn use a router outlet, but they are embedded one in one.
Yeah, they'll sit in the HTML template for
yeah. If you put two, I don't know if you have an error or something like that, but I guess Angular won't know where to display what is loaded in which one. There's no way to tell the system to load it there or load it there. Okay. Good question.
Patrick, so what I understand from what you just described, app.com/login, and if you're gonna be nesting another subfolder underneath the login, and if, for example, login page 1, right?
Yeah.
App.com login page 1. If in the page 1 we do have a lazy loading, then we would include a router outlet on page 1. Is that correct?
Exactly. If here, instead of displaying a component directly, we don't need a router outlet. If we define a new path, whatever you want to define, and then here, load children, blah blah blah, for lazy loading, then somewhere at some place in some component we need a router outlet. If not, this path won't be displayed because the system wouldn't know where to display it.
And that's only used for the lazy loading. And if we're not gonna do lazy loading, then we don't need the router outlet because it's gonna display right away. Is that right?
Yeah, it won't be used. You can put one, but it's just for lazy loading. Well, it can be used. You can trick a little bit of the system to do some weird stuff, but it's not meant for that.
Okay, usually for the lazy loading. Gotcha.
Yes. That's the reason for it to exist. Then, like everything in code, people just twist it and use it to find some way to display components. It's really complex and it's a little bit dodgy.
Got it. Thank you.
Okay, Enrico, all right? Everything's okay? Great.
Yep.
Yes.
Okay. So in any case, it's a little bit confusing at the beginning, but once you start using it, it's very easy. So let's go to the authentication module. So let me think. All right, so let's start at the beginning. So this service is in the shared folder because it is a service that we will probably use in many components. Each time in a component or in a page, think it's like React. Okay, think about a component like it was a page. Okay, it's just a display. So each time in a component, you need to know who is logged in. If the user which is logged in has certain permissions or right, or if you want to display his name, stuff like that, all this information is stored in this service. So it's a service that has to be accessible and available to all components. So that's why usually it's it's placed or located in the shared directory or sometimes in the core directory. I prefer to put it in the shared directory for what I said before. If you want to display a splash screen, you don't need to know who the user is because he has not logged in yet. So to follow the flow of this application in particular, we have this. So we start with the app module. The app module bootstrap the app, loading the app component, and also loading the app routing module. The app component doesn't do anything. It has an router outlet, so it will be in this outlet. It will be displaying what is inside the routing module. The routing module, the configuration says whatever you type after the initial address of the website, you get redirected directly here. Sorry, I'm going wrong. It's here, sorry. So whatever you type, you're redirecting to the login page. And the login page is a lazy one, so it has to load all this module, so it has to load the auth module. And as you can see in the auth module, you're saying, I'm going to use the sign-up component, that's it. And I'm loading the common module, which is necessary for Angular to work, the auth routing module, which is how I'm going to navigate inside this module, and also the shared module. Okay? And the shared module is the one, it's this one. It's the one where you place all the libraries and all the code that you will probably need in many places at the same time. And the way why you do that is because this way you just load it once. You don't load it each time you need it. You just load it the first time you need it somewhere. Okay? And as you can see here, obviously in the shared module, you also need the core module. Okay? In our application, doesn't make sense to have a core module. It was just because we just loaded at the beginning, but it's best practice. And here, then we have all the declaration. In our case, we don't have any declaration here because we haven't defined any component for the moment. And this is the place where we probably will use, well, it's already done, where we instantiate our Angular database and stuff like that. Okay, so once we load the share module, when we load the auth module, it's also loading the share module, the routing module. The routing module says same principle as the one before. Doesn't matter where you are inside the /login, it will redirect you directly to the root of this /login and will display the sign up component. When you go to the sign up component, okay, it's a normal component, nothing very special. It has a HTML and CSS. And in the constructor, we have a dependency injection here that loads our auth service. So for dependency injection, it's not something particular to Angular. It exists in many languages. And what it means is if you have a class or if you have code that needs initialization, if you need to instantiate this code before using it, you can use dependency injection for the system to take care of all the initialization. So if you do it like that, you include the service you need as a parameter of the constructor of a component, and what that does is load the service, execute the initial code, and return this instance of the service which is available to work with directly in your code. Okay, so since we are using this dependency injection here, we are initiating the service. So let's go to the service. So we are going to the workflow of the app. So we go to the service, and here, obviously, the service, the first thing it does, when it gets instantiated, it's calling the constructor, and the constructor, and its turn, same stuff. It will use also dependency injection to load three services, sorry. The Angular Fire Auth service, the Angular Firestore service, and the user service. So the first two are the one provided by the Angular SDK, sorry, the Firebase SDK, and the last one is the one we made on the last session. Okay. So let's say that once the code reach this line 17, all those 3 services are already instantiated. Okay, so they are ready to work. So this is the path that we have followed from the entry point, the bootstrapping. How did we reach this point? So I'm going to skip for the moment this part, which is the most interesting one, and we go to the just the login, which is not very well named. It's not login. It's both logging and signing and sign up. Okay, when you use social media for logging, basically what you're doing is you're using all your credential from somewhere else to create a new user if it doesn't exist, or to log in if it exists. So it's both things in one place. So the code is very, very easy to understand, I think. Firebase provides us with a series of providers, or social media providers. We have Twitter. We could also use just the email and password provider. Facebook, GitHub, Google. We could try to make a multi-factor assertion resolver, a standard OAuth credential. You can also have the phone provider to authenticate by phone. You can use reCAPTCHA, also SAML. So you have many ways to create let's say a signing or sign up provider. So we used in this case we use Google, but the principle is the same for all of them. You choose the way you want to authenticate, and you create a provider with it. Something which is important, and Thomas faced, and I don't know if you all read my answer in the Firebase. In the Firebase, let's go. Oh, I cannot go this way. Let me open. One moment. Okay, stop presenting. Okay, so I'm here in the Firebase console of our project. And here on the left, you have the big menu, and the first item of the menu is the authentication. Okay, so in the authentication tab or menu, you have 4 tabs: the user list, the sign-in method, template, and usage. If you go to sign-in method, you have a list of all the sign-in methods that you could use, but you have to enable them. They are disabled by default to prevent anyone to log into your application without your knowledge. So at the beginning, everything is disabled. So even with this code, the code I have passed you, it wouldn't work, because on your personal database, the Google or the provider is not enabled. So you have to enable it. If you want to enable many, you can enable all of them if you want. And then you can provide many ways for the user to sign up and log in. So back to the code. Okay. So here we create a Google provider object, and then we just call the sign in with redirect method of the auth service, of the first auth service, with our provider. So doesn't matter which provider it is. It's just a parameter of the sign in with redirect. Here we have two options. Okay, so we can signing. Let me. Okay, here we can sign in with pop-up, or we can sign in with redirect. Okay, it's let's say it's the same principle, but it works in a different way in your browser. Okay, so if you sign in with pop-up and you use it on a mobile phone as a web, it's not the best practice, because it will actually open a new tab on your browser, and then it has to go back. You have to close this tab, and you have to go back to the app. It's very cumbersome. So usually, if you know that your main target will be an app, a mobile app, it's better to use signing with redirect. What the difference is, signing with redirect will move from your actual app to the Google page, in our case. And then when you finish your process of authentication in Google, it will move you back to your app. So you don't have to change anything on your screen. It's transparent for the user. It's just the same web page that changes from your app to Google and back to your app. Okay. So if you do that, if you do it with signing with pop-up, and you do it on a PC or a Mac or whatever, on a desktop machine, then you will see a pop-up, and you do whatever you have to do in the pop-up. And once you click login or whatever and accept it, the window will close, and it will get back to your app, and you will be logged in your app. So it's a good sensation for the user on desktop, but not so good on mobile. The difference is this part here is not executed when you use signing with redirect, because at the moment you execute signing with redirect, your browser goes to the Google URL, so you lose your application. You lose your code. All this then is just deleted because you went to another website. So this won't be executed. This is executed only with pop-up, because with pop-up your app is on one page, and then you have another page, another tab, another window of your browser with your authentication process. And when it's done, it will send a request that is the process is expecting to get, and it will return in your then function callback. Okay, so not really important, but if you use signing with redirect and you're expecting to get the result here and do something with it, it will never be triggered. So keep that in mind. That's why nobody does that usually. Okay, so this won't be executed, this won't be executed, and this will be executed only if there's an error opening the new redirecting to Google. So what will happen in the workflow is, once we reach that, it will take us to the Google website, to the authentication page. We will log in, and when we finish logging in, it will get back to our app. And obviously, it would have set all the cookies that are necessary to ensure the correct authentication of the user. So you will be, when you get back to your app, you're not getting on the same state as when you left. You're getting back to the app with some cookies, and the cookies are your sessions, your session information on Google or Facebook or whatever. In our case, in Google. So what will happen under the hood is all the Angular Fire Auth, the service, this service is checking for all those cookies and checking them. So it's expecting to get some cookies, and if it found some, it will automatically check them against the Firebase server and gather all the user information that are displayed on the Firebase console that we can see. And then, and that's it. Okay. So what you usually do in a Firebase application is to use the auth state observable to get notified when there is some changes in the state of your or the authentication of the user. Okay, so this is an observable, so you subscribe to it. It's like a subject to which you can subscribe, and you get some notification in case there is something new happening. Something new happening could be the user has just been logged in, it has been logged out, or it has been deleted, or it has been blocked, or whatever. we can set custom claims. We'll see that later on. Every time there is something new on this particular user, you will get notified. Okay, and so there will be remember when we talk about observable, it's like a pipe where you can plug some components or some logic to do things with the data that is flowing through the pipe. And when you have finished doing everything we want in the pipe, then on the subscription you have the result of all these transformation. Okay. So let's go step by step.
So the information you get back about the user is purely in that user object that the Auth, Firebase Auth gives you, right? If you had created additional user details in, say, like Firestore, you'd have to call those separately, like if there's a change. So when you're listening to on Auth state change, right, waiting to see if something else came in, that's only those things that live in that initial object, right? Because I think we had talked about creating a user. There's two parts. You have the Auth part, but then if you had other details, you don't want to put them in that Auth object. You have Firestore that's connected. You wouldn't hear that unless you are somehow connect those events.
Exactly. So the way Firebase, this is particular to Firebase. The way Firebase work is, because it's a serverless, let's say, philosophy. You don't have to take care about storing authentication data yourself. Firebase is taking care of that, but just the authentication. So it means that since it's taking care of it, you cannot, or you have very, very, very few freedom about managing this data. You can add some 1 kilobyte of information to this object. That's it. You cannot do anything else. And from the client SDK, you can delete your own user, but you can't delete other user, obviously. You can't do stuff like that. So the auth, the Angular Firebase Auth Service and the auth state, which is basically when the state of the user changes, will return the data which is contained inside Firebase, and it's managed by Firebase. It's not something that you can really update or do things with. It is just the authentication data. If you actually, you can debug it, and if you look at it, you will see a lot of garbage because it's compressed and there is a lot of function. It's a complex object. It's very, very, there's a lot of information, but there's very little you can do with it.
Yeah.
So what you do usually in any application is you usually don't separate authentication and profiling. Usually it's all in the same place. You authenticate the user, and you enrich also this authentication data with his name, his photo, the permissioning, for example, or whatever. No, but you can't do that in Firestore or in Firebase. You have to create your own collection and store this data aside. You can't do that you could do that in the old, but very, very few details. Just 1 kilobyte of information, which is very, very, very few. Okay. So that's what we are doing here. So I'll talk about switch map after that, okay? So here, the flow is, when we instantiate this service, our auth service, we subscribe here. We subscribe to the auth state of the authentication service from Angular, and if you do that, basically nothing happens. You're just subscribing to the radio. You just turn on the radio. But if nobody is emitting anything, you don't hear anything. So this is what's happening here. But if you log in, or if you log off, or if you sign up, then there is a change in the authentication database in Firestore, and you will be notified by this change. Okay. So the moment you log in the app, then the auth state will be triggered. There will be a data coming into this stream, and this data will be piped through all here and then come out here. Okay. So The only thing that is going to be piped in from the auth state is an object of type Firebase user, okay, which has its own definition with a lot of fields and it's complex, blah, blah, blah. And this is what we get here. Okay. So what we want to do before getting into the code line by line, what we want to do is we're getting a Firebase user object. That means that we are authenticated in Firebase. So the user has the right to use the application. Okay. First, we have to check if we have created this collection with the additional data we want to store about this customer or this client or this user. Because in the auth object, there won't be anything like that. If we want to store his history or whatever data we want to store from him, we have to make sure that it exists in the database, in our database. And if it doesn't exist, we have to create one new document with all the information we want to store. So that's what we are doing here. So what we're doing here is first, we retrieve the user, or we get past the user. On this line, we check if this object exists. This is a way of, it is the same as those two are equivalent. Okay, it's a shortcut. So we want to check if the user is null, because imagine that the admin of the app went to the Firebase console and delete your user. You will be notified, and you will be notified in two ways. First, you will be logged off. So you will get a user but logged off, and then you will be notified there's a new null because you've been deleted. So this variable will be null. So you have to check if you want to do something with it. You have to check that it is not null. That it is actually something useful. So first we check if it's something useful, and then what we just do is we use the service we created before last time to get this user from our database. Okay, it might exist or it might not exist. At this point, we don't know. So we get the potential user, and then we check the same way we did before if this variable, if the result of this query to the database returns something valid. If the user doesn't exist, we will be null will be returned. Will be given a null object. So that's what we check here. If this variable doesn't exist because of the exclamation point, the negation of the object means that is equal to null or it is equal to undefined, both. If this is true, it means the user doesn't exist in the database, so we create it. Okay, so we've already creating. Here we have I don't know what it is.
It's a user service.
It's a user service.
So I have a question about that. If you go back to the auth service where this call this create user, we don't need to do like a this for this because we're in the scope of that user service already.
Sorry?
So here where we're saying create user from Firebase user. Yes. How does it know about this function? Is it because we are within the scope of user service?
No, we have imported here.
Oh, we imported it. Okay, got it.
I didn't see the user service. Okay, it's exported there. Yep. So here we import it and we use it.
Okay, cool.
Okay. So we created, this is a very dumb function. It takes some data from this object and construct a new object with another format. But it's just a mapping of the fields from the Firebase user object to our own user object. So it doesn't do anything very, very complex. So it returns our user object, which is there. Okay. And once we have this object, we save it here using the service, the function we already created. We just save the user. Okay. And that's it. In the case here, so we explain what we do if the user doesn't exist or if we can't find it in the database. But if we do find it, we just return it. Okay. And And here, if so, here we said, okay, we have something happened with the authentication state, and if what is happening is that we get a null, then we return a null. That we don't have any user, so we return a null. So then any call that will be made, or if we want to use the user anywhere else in the app, the user will be null. So we would have a way to check that nobody's logged in. So there are probably some places in the app that you won't be able to reach because of security or whatever. Okay. So once everything is executed there, meaning that the switch map here that you have plugged into your pipe has finished its job, it returns what you have to return. So basically it returns null or a new user. This is what we get here in the subscription, and we do that. So what is that? Okay. So this is, it's a little bit complicated to explain. Normally, what you do, I'm going to try. I'm going to try to be clear, but it's not that easy to explain. When you work with observables, think about observable as promises, but that can resolve many times. Okay, it's the promise usually get resolved, and that's it. It dies after it's resolved. It gives you the result of the promise, and then it disappears. An observable works in the same way, but each time there is a new value, it will resolve again. So it doesn't die after the first resolution. Okay, think about that. But the observable itself doesn't have any data. It's like a promise. A promise is just a specific object. The promise is not the data itself. So the alt state is an observable. So what you want to do, you can do things in two ways. You can, for example, create a variable called user of type user inside your service, get the subscription here, and assign the user to the user you get in the subscription to the user of the variable of your service. And this way you will be able to access this variable anywhere in the application that is using the service. This is okay way to do that. If you do this, what you make sure is that this variable, this user, will always represent the latest state of the user. It will be updated in any case. If somebody if the own user or the admin changes something in the authentication object or in the document in the collection, it will be updated. Okay, but if it's a variable, you have no way. If you're outside of this service, if you are in a component, for example, our sign up component here is using the service. Okay, so we can query here this service user. Use this variable, and each time we want to know the value of this variable, if we request it, we will get the latest version. But we have no way to get notified when it changes. I don't know if you follow the difference. Well, the difference between working with observable or working with the variable itself. If you work with the variable, it's a snapshot. So each time you take a photo, each time you take a snapshot of this variable, you will get the latest value. It will be behind the scene. It will be updated. So each time you request it, you will get the latest value. But you don't get notified if it changes. So if you want to take some action in case there is some changes, you cannot do that because there's no way, nobody will notify you. And this is very important for this particular object because, I don't know, imagine that you want to log out or you want to delete this user because it's abusing the app. You want the app to be notified immediately that this user doesn't have any access to, or if there's I don't know, if you granted permission to a user to do some stuff and some very sensitive part of the app, and these guys change department of your company, and then is not allowed anymore to access this information, you want to notify the app to restrict the user from accessing this part of the app. If there's no way to notify the app that the user have changed, then you can only wait for the user to refresh the app for the new value to be updated. So this is why it is very useful to use observables, because you subscribe to the observable, and each time there's a change, you get notified with the new value. But also sometimes the problem with that is that if you use the observable itself, it's like using a promise. If you want to know the value at a certain point in your code, you can't, because the observable, it's just like a pipe. So you have to wait for something to get out of the pipe. So you have to subscribe to this observable and store the result that is updated in the subscribe function somewhere to be used by your code. So it's a hard balance. It's a difficult choice to make sometimes, or at the beginning of RxJS, to use observable and to store the data in local variables. So what people usually did was in the service, they were not subscribing here. They were just returning the observable with any kind of transformation that you want to make, but they will return the observable as a user, and then in all the places of the application where you want it to be notified if there's any change in the user, or if you want to use the value of the user, you had to subscribe to this observable, which is cool. You can subscribe as many times as you wish. You just have one observable. Okay, so it doesn't increase your memory consumption or anything. It's just, again, think about the radio. It doesn't matter how many radio set you turn on and off. There's just one radio station emitting. Okay, so doesn't matter if one object subscribe or many objects subscribe. The consumption of resources is the same. The difference is that in each component that was subscribed to this observable, usually they will store the value returned by the observable as a local variable. So you will store the user, in this case, as a user variable with the actual data to be able to display some value in the template, in the HTML, and to do something with it. Okay? If that's the whole point of it. You subscribe to the observable to get the value, and sometimes you want to react to your change, but sometimes you just want to display the value and have the variable available in your code. So with observable, so in this case, what people usually did at this time would be to replicate the user data in many components, and these are useless memory consumption. You have the same data in every component because you use it everywhere. So it's not very efficient. So then the guys that write RxJS created a new object called subject or behavior subject. And behavior subject are really cool because they are both actual value and observable at the same time. Okay, so here I'm just defining a user variable as a behavior subject of type user. Okay, and I'm instantiating it. So now the user exists. Let's say this variable is something. It's a behavior subject. And what I do here, let's forget about that. What I do here is I take this variable and I use the next function. And the next function means that since this user variable is both the value and an observable, I will emit a new value I would say, okay, inside this observable, now there's new data available. So that's what you do with next. You just put next with the data, and everywhere other places of the code that are subscribed to this variable, they will be notified there is some new data. But also, so that's oh, I'm not doing it here. So this is an observable. Okay, it's like an observable. But what I also can do is, let's say, for example, an example. Okay, imagine that in our component, it's same component as the one we have here. We have access to this variable from our auth service, which is an observable, and we just display the picture of the person. Okay, we just display that, and because it's a small component, it doesn't take a lot of place. It doesn't take a lot of place on the screen. But we want also to be able to display the rest of the data on the bigger place, on a box with all the name and family name and age and whatever data we want to display. So, for example, we can put a button under the photo, the picture, and if the user clicks the button, we display the rest of the information. Okay? So far, so good. So what we need is a way when the user clicks the button to get the user information. But since if it were just an observable, we don't have that. The observable, it's not the data. So what we can do is we use the behavior subject value function or value property. And this will give you the actual value of the user. So that's why I say it's both the actual data and an observable. So I can do that as observable, and then I can subscribe to it, or I can use value. So it solves the problem I was commenting before. So because in this auth service, I define this variable with the behavior subject, and I actually store the data here, but I'm just storing it once. And then I can use it both as an observable or as value anywhere else. But I don't have to create X local copies of the data. Okay? And it's...
So everywhere that you would need this user, you would import in the auth service and then call the auth service that user $value if I need a value. Okay.
Exactly. That's exactly what you do. And since it's an observable, you can also use the pipe and transform it. For the user, it doesn't make any sense. But for example, if you're working with data, maybe in some part of your code, you're displaying some part of the data or very raw data, and in other places, you're displaying transformed data, like aggregated data. You don't have to create multiple copies of this data. You can use the same observable with the raw data, and in the component that will display aggregated data, you pipe a function, a map or a switch map. You transform this information into what you want to see, and then you output it. But you don't actually store anything. You're just making calculation on the fly. So each time the data changes, it goes through the pipe, do the calculation again, and output whatever the result of the calculation is, and you can display it. Okay. So let's make a pause. Is it clear for everyone? Probably you should have questions because it is very complex. Yes.
The only question I have is what would happen if how would we do that just by using like the data, not the observable, not by using behavior subject, by like doing it the old-fashioned way you explained before? Can you like repeat that?
Yes, you can do it. Okay, so let's say, okay, so the code was that I define a variable here, user, okay, which is the variable I want to use outside of my service. I want the service to provide the value the service wants to provide. Oh, sorry, the return, it's not here, it's there. Okay, so the flow is, if there is a change in the authentication status in Firebase, we will get notified here. We will run all this code, which is we're going to check if this authenticated user exists or not in our database. If it doesn't exist, we create it. If it exists, we just get it. Then we return it. So all this code is doing this. And then when we finish that, basically we're returning an existing user from our database or null. And here what we do is we get this result. And what do we do with this result? We assign it to the user variable of the service, okay? Which is a public variable, so we will be able to use this variable outside of the service. That's the main goal of it. So let's imagine that we get into the app, we log in, so this is triggered, everything runs, there's a new user created, and then this new information is stored in this variable. Everything's fine. And this object is an object we created in our database. So imagine that we also have permissioning. We have in this data, we have information about what section, what part of the app the user has the right to see, and what part he has the right to also change, if it's an admin or if it's just a bare user, or you know what I mean, no? The privileges that the user have. If we do it like this, and the user, okay, so this is running in the background because it's a service, it's not displaying anything, and we use it in a component which is displaying sensitive information. So the first time we reach our this component through the routing system, it will check, or it will get this user variable from the service, check if this guy has the permission, the privileges to access the information, and if it's okay, then everything's cool, and it works perfectly, and nothing happens. But then, for any reason, there is an admin from the app that get told that this particular person shouldn't have access to this info, which is a very sensitive info, that it's illegal that he can have it, etc., etc. It has to be, it has to be forbidden from accessing this information right now. If you use this variable, there is no way you can notify the app that the situation has changed, okay? Because the admin will change the status of the user here. This code will be executed. This code will also be executed, but no, it's not here, sorry. Keep typing in the wrong place. So this code will be executed, but your component won't be notified because it has just checked this value at the beginning, and it won't be notified that this value has changed because it has changed inside the service, and you are using it inside your component. So it will look like that. So let's imagine here also in the component, public user, I want to have a copy of the user in my component to display information. And I do the same, this user equal to this Auth Service user. So when you reach this component, it will execute the constructor function, and it will execute this line. And these lines mean go to the Auth Service, get the user variable, and assign the data containing the user variable inside this local user variable. That's a snapshot. You get the value, you store it there, and you forget about it. So after that, if there's any change in the Auth Service, because this has been triggered, you don't know. In this component, you're not aware of these changes because you have taken a picture of the value of the user here, and that's it. You're not notified that this value has changed. I don't know if I explain myself.
Yeah, I get it now. Okay, I see. Thanks.
Okay, so you need yeah. Sorry, Sam.
Patrick, I have to drop for my other meeting, but I'll talk to you later.
Patrick, I have a question about so how we can tell if it's a snapshot or dynamically changing data, which is if it's a variable or observable. How can we tell?
Well, that's the beauty of TypeScript, because you have to define, or you should define, the type of object you're using. So here it's a behavior subject, so you know it's a sort of an observable. And here you're defining user as a user, which is just a normal class, normal object. So you know it.
Oh, okay, gotcha.
So if you go to user dot, you get the property of a user. But if you go here, there's nothing about user. There's just weird stuff about the behavior subject. But that's what's cool about strict typing or strong typing languages. The other thing is, a very good convention is, each time you use a variable which is an observable, that's why you suffix it with a $. Okay, so this way it's a convention. It does nothing with the code. It could be something else, but someone came up with the $, so it's a $. So you know in your code that if a variable has a $sign at the end, it means that it's an observable, and it means also that you won't have access to the data directly, except if it's a behavior subject. Okay.
Got it.
So this way of, so I'm going to delete this and this and this. Okay. So this way of managing your data is a sort of state management. So there is a lot of debate, or people arguing about if it's necessary or not using a state management library when you work with Firebase or Firestore. And I had a very interesting discussion on Slack about that. And we reached the conclusion that most of the time it's completely useless to use any kind of state management library with Firestore, except if you have data getting from different sources. So if you have data from Firestore and also from a normal traditional SQL database, then it makes sense, because you have to put all this together and then manage the state in a coherent way. But if you just use Firestore, it's useless, because Firestore itself it's already a state management. Okay, but if you, as I just explained, if you only use observables, then it's a bit of a struggle to get the actual value, and it's hard to work with it. So this pattern to create in your service behavior subject to hold a local copy of your data and not to get rid of the observable behavior is a very good pattern for that. So you define you define a variable as a behavior subject, and then every time you need an observable, which is basically what all the function from Firestore return, you assign, or you use the behavior subject to store the variable in the local object. In this way, you have the best of both worlds. Outside of the service, you will be able to subscribe to this variable to get notified of changes, and also to immediately get the actual value of it. And as an additional benefit, you only have one copy of the data located inside the service. You don't have to replicate the data everywhere. Because as with promises, observable are a source of memory leak. Meaning, if you subscribe to an observable and you forget to unsubscribe, under the hood, the system is still subscribed. So, for example, here, in this case, I will explain later or another day why it's okay. But usually, if you have a service, in this case, with an explicit subscription in the constructor, meaning that this will happen anyway, I'm subscribing to this observable. So under the hood, inside the Angular library and the RxJS library, there's a lot of process that are actually expecting data and consuming memory working for that. But if this service is destroyed at some point because we went from one page to the other and then the service is destroyed because you don't need it anymore and you haven't unsubscribed, behind the hood or behind, yes, it will still exist. The subscription will still exist and the system will still be notified. But there's no actual code that will use this notification anymore. So you will, you will have like ghost processes. Each time you go to the page and then go elsewhere, come back to the page, go elsewhere. Each time you're going to create a new subscription and don't delete it, and create a new one, don't delete it. And this will obviously create memory leaks at the end. Okay, so it's you have to be careful with observables. That's why it's much better to have the main subscription and all the stuff in your service, and you manage it everywhere, everything here. And then you expose the behavior subject, but because they are not actually observable, so it's easier to manage the subscription stuff. But this is for another story, another session. So exactly for this reason, if we go to the sign up component here, as you can see, it's a very, very easy component. We have we create a local variable as an observable of type user. We assign our behavior subject to this variable, meaning that after this line is executed, this object will contain an observable that will lead to get the data at some point. And then we have two functions, one for sign up and one for sign out, just using the authentication function we define in the service. And what's interesting is the HTML. Okay, so I'm going step by step. Forget about the ng container and ng template and all that stuff. Forget about it for the moment. Just focus on this. This is an observable. So as an observable, it doesn't have any value itself. You have to subscribe to it to get the value. Okay. But since Angular is all communication inside Angular is based on observables, there has to be a way of using them in an easier manner than subscribing in the component and taking care of not forgetting to unsubscribe and not entering the risk of memory leak and stuff like that. And this is the async pipe. So in the template of Angular, there are a lot of sort of function called pipes that we will study after that later in a later session, which are let's say that this syntax will be more or less equal to this syntax. Okay, but since it's in the template, it has to be a little bit different. I don't know why exactly. I think because you can chain them, whatever. But don't be scared about this. The pipe here, if you have a variable, then a pipe, then another name, it means that this is a function and it's applied over that. Okay. So the async pipe, what it does is exactly what we wanted. It will take care of the subscription and unsubscription of the observable. And it will store the value in the one you specified as user here. So this means subscribe to the user observable, and when you get a value, assign it to the new user variable, which only exists inside the template, inside this HTML. Okay, this is what it means. It also means when this component is destroyed because we went to another place in the app, don't forget to unsubscribe. It will take care of it. So if you use the observable with the async pipe in your template because you don't need it on your page because it's just to display stuff, you don't have to worry about memory leaks. Angular will take care about subscription and subscription of everything. So that's cool. So you can use that in all templates, and this is the best way to use it. So the actual template here, that's the following. What we want to show is the following. If we are logged in, we want to show these two things. We want to show an H2 title with some text, okay? And inside the text, we want to display the username, and we want to put it with a title case, meaning that each word begins with an uppercase. And we want also to display the JSON representation of the object, all the properties, etc. But if we are not signing, we want to display this, that we are not signing. And the way to do it is the following. You create a container. Ng is for Angular. All the components in Angular start with Ng. So an Ng container, you put an if directive, and you say, okay, let's subscribe to this observable, assign the value of the observable in the user variable, and if there is nothing in this user variable, show the piece of code which is labeled not signed in. Okay, and the ng container is, as its name shows, it's just a container. It doesn't display anything. It just run code. So if this is something, if user is something, then it will display that. If not, it will display what is labeled under not signed in, which is another template that you label this way, and that you can, and then you display. Again, ng template is not display itself. It just display what is inside. So I don't know how you do that in React or in Vue. I don't know if there is something similar that you can do. Probably yes, I guess, because you can mix code with a template. In this manner, Angular is a little bit more complex than React and Vue because it's not JSX. You cannot write code and say if this variable is something, then the template is this, and if the variable, you have to write everything in a template using some specific instruction and components. So you have to learn that. That's more cumbersome. Any more question? Yeah, shoot.
It was the question I made on Slack about what's the difference between what is it again? Backend and cloud functions.
It's basically semantics. It's fundamentally they are the same. The difference, let's say the philosophical difference, is that what you usually call backend is the traditional way of the architecture of a web application, where you have a server which is doing all the hard work, the heavy lifting. Meaning you have a machine, a server, which is holding all your static files, all your HTML and JavaScript files, CSS, etc., images. They are just files that are there, and when your browser connect to the server, it will request the files, and then it will execute them. And when you want to do stuff that are, or things or features that are requesting more processing power, or if you need for security reason to process the code outside of the browser because you don't want the user to know how it is done, you have to do it on the back end. Okay, so you have to issue a request to your server, to the back end, asking him to do some stuff. Okay, so it will get some security stuff done with using some secret API keys, or it will do some machine learning stuff, which is very heavy in terms of calculation process, stuff like that. Because it's a big server, it's probably scalable, it's a big machine, it's not like a mobile phone. So you need processing power, or you need security or confidentiality. So this is what backend server usually is. So you have many endpoints, you have many, let's say, windows where your application can go and ask for some task to be done and expect a result, or wait for a result, and when the task is done, get the result and then display to the user. That's the traditional way. But since we are using serverless now, we don't have any backend here. Here, all the code is done inside the browser. So the only backend part that we have is, once we have created our app, we have to host it somewhere. We have to put it on the server. All these files, the 6 or 7 files that are generated when you compile your application, they won't change until you compile it again. But once it's compiled, those files are static files. They are just what they are. So you have to store them somewhere that everyone can access. So it's the hosting part of Firebase. That's the only backend stuff that we have. But there's no logic. There's no processing power there. It's just a file repository. That's it. It's a CDN. So what happened when you are in a situation when you're working with a serverless environment and you need whether big processing power or confidentiality, where for the code to be executed in a way that the user cannot see it. That's why you use microservices. And Cloud Function, they're just microservices. It's not a big server that has a lot of function to do. You create function that each function does something precise, and that's it. And it's completely independent from the other function. Okay? The other very, 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 very big difference between functions and a backend is state management or session management. What that means is, when you're working in the traditional way with your browser and the backend, you authenticate against the backend, and inside the backend, it creates sort of a database of who is logged in, who's not logged in, and a lot of data on when, where, what is the IP, and all that stuff. Okay, and it will create probably a cookie. It will return the cookie to the browser, and then through this process, each time the browser make a request to the server, it put the cookie inside the request, so the backend check the cookie against its database, and if it matches, it means that the request is authenticated, so you can actually do the work and give back the result. And you also have state, meaning that not only authentication, meaning that you can persist the data internally inside the server. So imagine that you're doing some calculation on your front end. So you're adding 2 + 2, and you're sending the result to the backend. The backend could store the result. It could store 4 inside a variable, and then the next person accessing the backend and saying, what was the last result of the calculation? And the backend could say it's 4, because it's like one session. Okay, it's like one process. So you could do state management inside your backend. It's not recommendable at all because it's not scalable. There's a lot of inconvenience, but you could do it. Usually, a long time ago, it was done like that. If you use microservices, or if you use Cloud Function, you can't do that because the function, they are just created. I mean, they create a machine, a virtual machine, to run the function when you ask for something, and when the work is finished, the machine is destroyed. So there's no state. So
Okay, I got it now. So it's like with Cloud Functions, you don't have like a specific server for you. It's just like, you know, random a Google server from like wherever. It just it does the job you want it to do, and then it shuts down.
exactly.
Okay, thank you.
So there's no state, and since there's no state, this is why there are a lot of warnings on the Firebase website saying that the Cloud Function should be idempotent. An idempotent function is a function that no matter how many times you run it, if you pass it the same parameters, it will always get the same result. So it seems easy, but it's not that easy, because if, for example, you could have a function that adds some file to some drive, and so you will oh no, it's not a good example. Let's say you have sensitive data, okay, that you don't want the user to know about. So, and you want in the user, for example, I'm trying to imagine some information. Okay, I have an example. You want to create a function that returns a picture, a given picture, but with a watermark. Okay, because it's a copyrighted picture, and you don't want the picture to be used in the wrong way. So the user can ask for a specific picture, but it has to be through a Cloud Function, because the Cloud Function, what we would do, it would fetch the picture you asked for and process it with any kind of graphic software that you can install there, and create a watermark, some mark on the picture, and then return the newly created picture. So if it's always the same watermark, it's okay, it's idempotent. But imagine you want to put a timestamp in the picture saying that this picture is copyrighted by blah, 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 and this picture has been created on this moment, on this timestamp. It's not idempotent because the result is not the same. So if you ask for the picture today, you will have a different picture that if you ask for the picture tomorrow. So this won't be an idempotent function. It's not very important to have different picture in this case, but you can imagine scenarios where the result is different. For example, if you want to add 1 to a field in a database, you issue a request to the function, then the function goes to the database, it add 1 to a field and return 2. Then the next guy requests the same function, it will return 3, and then 4, and database will increment ad infinitum. So this is not good. It's not a good way to. There are some exceptions, but you should not use Cloud Function this way.
Okay, thank you.
Enrico, you're very quiet.
Yeah, I know.
You're jet lagged.
I think I'll need more time to process everything.
Probably it's a lot. It's a lot.
Yeah, also because I'm used to Vue, so I recognize some correspondence, like in the template. In Vue, we use directives very similar to those to display parts of the component based on the state. So it's very similar.
Yes. I haven't talked about that because I suppose everyone was aware, because it's the same with React and Angular and Vue. You use the the double curly braces or single curly braces. It's more or less the same. It's very easy to understand that inside your template you can use some code variable. And the magic of all this framework is that you don't have to take care about updating anything. If the variable changes, then it's reflected on the screen. That's the beauty of it.
Yes, indeed.
Imagine that 10 years ago, you had to process everything. Each time the variable changed, you had to rebuild the screen by hand. You have to write all those processes. It was crazy. That's why the pages was done on the back end. Because if you have 1 million users, you don't want all the pages to be rendered on the browser, because first the browser, it was Internet Explorer, it was crap, and the machine was crap, and you need mainframe, very powerful mainframe to do all that. So it was a completely different paradigm. Now we have mobile phones that are thousands of times more powerful than the PCs or the servers of 15 years ago. So yeah,
True.
The only thing we have to be careful about is memory leaks, because at the end you will still have, even if it's like 2 or 3 terabytes of memory in your phone, there is a limit. If you have a memory leak, it means that it's a process that consumes memory in an infinite loop, and it increase. So a long time ago you reached the end very quickly. Probably now you will reach the end more slowly, but you will still at some point reach the end of the memory. So this is something that we will always have. But the rest, in terms of computation processing power, now you can almost do machine learning inside your mobile phone.
Patrick, actually, I have a question. Every time we navigate to a different path through the router, do the previous components get destroyed?
Yeah.
Okay.
Yeah, that's how it saves memory, because actually you don't navigate anywhere. What the router does is the component that were used to display stuff on the screen, they are removed from the DOM and they are replaced with the new ones. So
Okay.
it gets rid of all the code. So all the variables and all the memory allocated to those variables get garbaged. The DOM is cleaned, and then the new component is drawn. That's why it's called a single-page application, because you only have one. There's only one page, which is index.html, and everything is inserted through JavaScript inside the DOM with shadow DOM and stuff like that.
Cool.
Very far from the scope. So yeah, it's very important to understand that even if you put some new address in your address bar in a single page application, you're not actually doing any request to any server. It just stays inside your browser, because it's all managed by the router module, or whatever it's called in any library of SPA. There's nothing that goes out. That's why, for example, when you're on a web page or a web app on your phone and you lose connection, you can still use it, because it's not requesting anything from the server. It already has all the code, except if you have lazy loading, and then you're screwed. But if everything you need is already loaded in the code, then you can work with the app and it's okay. Obviously, you don't have access to any data, because you have to fetch data from the server. But what is the skeleton of the app? It's all there. More question before we finish?
So Patrick, in my understanding, you just described how we don't have to fetch, we don't have to request for a server every time when we are going to another page on our application, because it's already stored in the application. But don't you think that it's going to take a long time and a lot of data to get from the server at first time when we load the application?
Yes, that's I was explaining at the beginning. That's why you use lazy loading. That's why
Oh, there's a
you split your application in small files that are loaded when they are needed. You don't load the whole bunch of the application one shot at the beginning. You could do it, but as you said, if you are on a slow connection or if the application is really big, then it will take a long time for the app to load, and it's a very bad user experience. Probably the user will just navigate away because it's too long to load. So that's why
gotcha.
what you usually do if you want to make a very broad public application is to have a starting page which is very, very basic with no code, very small file, a few kilobytes at most, and that's it. And from there, you go loading the modules. It's step by step. So that's why we have an authentication module. We have one feature module, another feature module, another feature module, which are only loaded when we want to use this particular feature. So, and you can also do something called preemptive loading, meaning that imagine in our case, first thing we load is the splash screen. Welcome to our app, just pure HTML and CSS. So a few bytes. So it's immediate. So the user has something to see. Then he click a button for login. When he clicks the button for login, we load the code that take care of sign up and logging and everything. But usually this process takes some time. The user has to input his name or his password, or he has to click on the Google button and then go to Google, authenticate there, and then get back. So it takes some seconds. During these seconds, the app is idle. It doesn't do anything. It's just waiting for the user to input stuff. So what you could do is instruct the app that during this idle time, download the rest of the files. Even if you don't need them, maybe sometime you will need them. But since the app is not busy doing anything and the user is, you have display what you had to display. Nobody's waiting for you. Keep working. Just download stuff if you're going to need it later on. So that's preemptive loading that you could do also. But, it's a cool technique, but it's a lot of work. And if you're not planning for your app to be used in remote places in India or in Africa, doesn't make a lot of sense. Because if you think your app is going to be used in urban area of Western world, we all have at least 3G, if not 4G or someplace 5G, which is 5G is more or less the same as your home Wi-Fi. So all this stuff about lazy loading, it will disappear at some point because the network connection won't be a bottleneck. It all appeared because it was a bottleneck when we have, before 3G, when it was like very, very slow. You had to take care about that because it was a really bad experience. But nowadays, it's very rare that you have to wait for an app to load just because it's a lot of data. Sometimes you have to wait because the server is busy doing something else. This is another story. It's not about huge file size. It's about you haven't dimensioned your machines big enough to attend all the requests. Another problem. But nowadays, you can try. You can try. Some speed tests. There's plenty of web pages when you can check your internet speed connection on your mobile phone, and you can download a lot of megabytes in 4 or 5 seconds. And usually a web app is 60, 80 megabytes, 80 kilobytes. It's a small app, 100 kilobytes. So it's instantaneous.
Absolutely.
Doesn't make so much sense now than before. But again, we don't live all in New York or in Western Europe, Western world. So there are a lot of people in China and in India, and they don't all have very good connection. If you want to target those people, then you have to make the effort.
Got it. Totally makes sense. And future looks bright.
Yeah. Okay. What do you think we should tackle then after that? We have done the logging and signing. I guess my idea was we could make the user page, and this way we could see how forms work in Angular. So it's not a very important page. It's just a page where the user can change his name or put a picture or new URL or input some data. Okay, so it's a very normal, not very structured, not very complex thing, but it could be a good example to teach how to work with forms in Angular, which is pretty awesome.
Yeah, sounds nice.
Patrick, would
Yeah.
this be the right time to also maybe implement just placeholder pages to test the authentication while
Well, you
navigating?
already have it. I
But we haven't
the,
tested them, though.
huh?
We haven't tested them.
Oh, you want to do testing, like unit
Yeah, just
testing?
to make sure that people can access what they're supposed to and nobody can see other things.
Oh no, that's okay. No, it's not unit testing. You mean, I mean the app.
Authentication testing, if you will.
Yeah. Okay.
Like
have
route
you been able to run the app or not?
Not yet.
Okay. So let me. Sorry, I'm going to close everything without saving. Okay. Okay, and let me. Okay, so you're seeing my screen, no? My Chrome.
Yes.
Yeah. So in VS Code, you type npm start, and it starts the local server where you can debug or test everything locally. And the address is localhost 4200, and that's it. I don't know if you see it. I don't know if you see it because I cannot put it more bigger. Can you see the address correctly?
You turned your screen off, I think.
Yeah, we don't see the screen anymore, Patrick.
Oh, you don't?
We saw it for a second
Oh,
before.
and now? Oh, present now, window. Okay.
Yep.
So now you see it, no?
Yes.
Mhm.
So you're seeing the localhost 4200.
Yeah.
Yes.
Okay. I don't know if it's too small, maybe. I don't know. Okay. So remember that in the routing in the routing files, we had some redirect. If we
Double
reach
star to log in.
exactly, if we reach anything from the root of the app, in our case it's localhost 4200, we will be redirected to login, and then from the login route, then it will lazy load the login page. Okay, so if you watch carefully the address, I'm going to hit enter. You will see that it will take a fraction of a second, which it will load the first part, and then it will be redirected to login instantaneously. So I hit enter now. Oh, it's too quick. Sorry. Do you still see the screen?
Mm-hmm.
Yes.
Okay.
But we saw it refreshed it. So
yeah. So it's at the first time you do it, it takes like half a second and you can see it. So this is the app. So there's nothing else. So as you said, if you want to test it, we're not signing. I can log in with Google. Oh, sure. I haven't put the environment file. Where are you? here. Okay. I click login, then I'm redirected to Google. I sign in. I wait for a second, and that's it.
Cool.
Okay.
Cool.
So I can put that on the side. Console. No console, no source. Okay. Okay. So let me one second. Let me illustrate. I will get back again. This one, and go to authentication, and I will delete this user. Okay. So the app. You're seeing the debugger, no? The
Yeah.
debugger is okay. Core module, it's in shared and services, the auth services, and then here you can put the breakpoints. Okay, so let's see to show what I was saying before. And let's put that here and here and here and here. All right, so I've refreshed the page. So as soon as we get to the login page, we are in the sign up component. The sign up component inject our authorization service or auth service. So it has to be constructed before. So the first thing which is run is this. So it goes to this first line, and then it will enter the pipe. Okay. So here, the first thing that the auth state said is that there's no user. I don't know who you are. So we are notified of something has changed. We have tried to access the Firebase, but there's no user. So FB user is null. So since it's null, we return null. Okay. And that's why in the template, we check for the user. If it's null, we display this. And if it's not null, we display the data. So now, now I do login with Google, and then I'm running this. So first I build a Google provider, which is an object that Firebase provides us. And then I will run the signing with redirect with this variable. And if this is successful, it should go there. The problem is that since we are moving from our app to Google, the code is destroyed because we've changed web. We've changed the web, we've changed completely the address of the website. So this can't be executed because it doesn't exist anymore. See, it's destroyed. There's no more app. So here I'm at Google. This is Google. I'm not in my app anymore. My app is gone, away from memory. So I log in, and I'm back to my app, and I'm back as like a fresh new. So I'm starting again the same way. I'm starting constructing the auth service. But this time, since I already have authenticated, the auth service says, oh, I know you. Okay, and it gives you a Firebase user, which is an object with all these properties and functions. Okay, so a lot of code that you cannot do. So you have a display name, you have an email, very important, an email verified, and that's it, basically. And phone number, which is null, and the photo URL, a refresh token, blah, 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 stuff like that. So since we have a user, we're going to try to fetch this user from the database. And because I've logged in before, I already created a user in the database. I forgot to delete it. So here I have all my user data that I've stored in Firestore. So since I have the data, I just return it. And since I have a user, I can display the other code. That's it. Okay, so this is the way to check if something works. So in terms of how to work, what I usually do what I do when I build an app, and it's quite complex, and I think it's a very good process here to not to shoot or to aim at many things at the same time. We're not going to spend time on UI, okay? Because it's a completely different skill set. Okay, it's more design. It's more about how to place things and make the user experience great. It has nothing to do with the logic of the code. Okay, so what I'm proposing is, because I think the most value can be get from me, at least, because I'm not a specialist in UI or UX, is about the logic and the structuring of the code. So we're going to not to spend time on designing the very beautiful UI for the time being. We just do with basic controls and dumb component and very ugly stuff. And if we want, once we have reached some point, we could try to maybe talk to someone that is much better than I am on UI, and just focus on UI and design the UI. I think it's a better approach from trying to make some code and fight with CSS and to align stuff and to choose the colors and go back to the code, and because it's just changes in your mind. It's very complex to follow everything. I don't know what you think.
Yeah, I agree.
Agreed.
Cool. Okay. End of the story. So
I got a question about.
Sure.
Got a question about the forms. So, are we going to be focusing on the reactive forms or template forms?
Yeah, reactive form. Template. I never use template form. I mean, it's okay, but it's basically like it's HTML. There's not a big difference between pure HTML. It doesn't. I mean, you don't take advantage of the Angular power.
Okay.
I don't know. I don't know if you know it. I don't know what you think, but it's very easy to understand how template form work.
Yeah.
The reactive form is much better. It's a little bit more complex, but it gives so much power. You can do so much stuff with it. It's really nice.
Great.
Again, if you're starting now, everything looks normal, but when it's like people that used to ride horses to go to work, and then there's a car. So it's like wonderful when you fight so much with very hard stuff and raw material, and now you can just throw some stuff and the framework take care of everything. It's so cool. But we'll see that next time.
Nice.
Okay, I have to go.
Yeah.
Guys, pleasure to talk with you again.
Thank you very much for your session.
Wednesday. It's every Wednesday.
Wednesday.
Well, Wednesday is 7 p.m. Spain time, or Paris time, or Italy time. I don't know. You're based in New York, no, Sam?
No, LA, Los Angeles.
Okay, LA. So you're the one that are more. It's a very soon for you, no?
Yeah. It's about like 10 o'clock in the morning. So.
Oh, it's okay.
Yeah.
Okay, it's okay. That's why we.
Yeah,
that's
it
why
works
we close.
perfect.
For me, it's okay because it's after work, and it's okay for, I guess, for the guys in New York and the East Coast. It's beginning of the afternoon, something like that, no? And for you, it's not too early.
Yeah. What time is it now? At your time?
It's
time zone?
New York Times. I don't know. I think it's 6 hours from me. New York time. New York. It's almost 3 o'clock, 3 p.m. in New York. It's almost 9 p.m. for me.
9 p.m. for you. Oh, right.
Yep. So I have to walk the dog. She's gonna piss in herself. I have to go now. she's expecting me.
All
Talk
right.
to you. Talk to you next
Great
week.
talking to you. See you next week. Thank you.
Bye.
Bye-bye.